Welcome to the first in Astera series of Centerprise Best Practices webinars. This webinar will look at the ways in which the features in Centerprise can be used to build and maintain high-performance warehouses. Please be sure to type in your questions, and at the end of the webinar, we'll answer as many as time allows for. We'll capture all questions and answer them in a written Q&A document, and that will forward you after the webinar. Now I'll turn you over to our technical expert, Mike O'Quinn, who will be presenting today. Mike?
Hello, good morning, everyone. Thank you, Munir. I'd just like to reiterate that we are answering questions at the end. We've set aside time for that. So please write them along the way. I will not address them till the very end, though. So, but we will have somebody fielding them that may be able to answer, to make clarifications along the way. So feel free to ask them as early as possible. My name is Michael Quinn. I am giving today's demonstration. I am also the support manager, so if you've had any sort of questions about Centerprise, you probably have gone through me at one point, dealt with me at one point. I also do a lot of the demonstrations and training for Astera software regarding Centerprise as well. Today we'll be looking at how Centerprise can be used in conjunction with the data warehouse, specifically best practices as far as reading data, maintaining foreign keys using lookups and things like that. Best practices, tips for performance, getting the most out of Centerprise when using the components. And finally, we'll take a look at best practices for development and how to achieve collaboration in a typical large project, as one would expect to see when dealing with migrating between one system and a large complex database such as a data warehouse. So today's webinar is entitled Working with Data Warehouse, but all of these best practices apply to any database writing. The only thing that is that with data warehouse, you're typically dealing with large volumes of data, so any sort of scan or read or write is prohibitively expensive. So you want to just make sure where you're doing that and make sure you're doing it in the best way possible. So let's take a look at the overview of Centerprise and how it can help in this venture. So specifically usability. This empowers business users to manage information assets. Has an intuitive drag and drop. Someone's got a live mic here. It's a lot of reverb. There we go. Nope. Still echoing. Okay, so Centerprise has an intuitive drag and drop interface designed for business users. You can develop these very complex and large data migration and synchronization applications without a single line of code. We have the single-click data preview, which is basically your debugging tool on Centerprise. Scalability is very important when dealing with data warehouses as your volume increases, so does the load placed on all your resources, including the machine which executes these transformations. So Centerprise is highly scalable. It's 100% .NET secure platform. It operates in batch, change, or in real-time mode. So depending on what you choose here is dictates which route you go as far as how you design your data flows in Centerprise. We connect to all major data warehouses, including and also flat files, fixed length files, limited files, hierarchical data such as XML, EDI, JSON, and even your own custom hierarchical structures. We also support cloud structures, cloud services such as Salesforce.com, Dynamics CRM, QuickBooks, and more. So maintaining a data warehouse is particularly tricky because of the sheer size of it. And data quality becomes a very key piece of it. A lot of times it's the top barrier into successful warehouse and analytical implementations. High-performance data warehousing is all about achieving speed and scale while effectively managing increasing complexity and concurrency. Centerprise can deal with that as far as the data complexity goes, because Centerprise is inherently built to deal with complex data structures. Any sort of one-to-many, many-to-many, one-to-one relational structure can be easily accessed and harnessed in Centerprise. Data quality has the inbuilt data quality piece, the module built into the platform, so you don't have to change applications. You can do it all in a single platform as part of a single job in some cases, as it makes sense. And the speed of scalability, Centerprise is built from the ground up to deal with scalability. So the idea is that if you need more power, just throw another Centerprise server in, and your performance will scale accordingly. So you still have concerns with, of course, network bandwidth and overall storage capacity and database processing capability. But as long as but all of those are already scalable if you have the correct person working in your network. The idea is that we don't want Centerprise to be the bottleneck, and it's been developed to not be the bottleneck. And it also gives IT business teams it also enables IT and business teams to inspire confidence that their data and deliver the promise on their data warehouse. And we have a lot of successful customers you could look up on our customer stories on our website to see how they've used Centerprise successfully in some sort of data warehouse capacity. Okay, so the first section I'd like to discuss is data quality. Data quality consists of a lot of times data profiling. So basically taking a look and see what you have in your data stores and make sure that they conform to what you expect them to have, or as part of meeting some sort of criteria based on some business logic. You also might want to validate before embarking on a data migration process, or maybe even as part of the back end of the logging, and make sure that the data that you have moved in, you want to see, okay, what kind of error rates, what kind of failure rates did you have in doing so. Centerprise allows you to do this with a couple of features, namely the data quality rules component, the field profile, and the record level log. So we'll take a look at those and how you can use those in Centerprise. So right here, this is what you're looking at, is Centerprise Data Integrator, for those of you who are not familiar. It is the client portion of our system, meaning that it's responsible for creating data flows. So what you're seeing on, just going to give a brief tour of what you're seeing on screen for those of you who are not familiar. So it's a Windows application, a dockable window application. So you see all these windows here. You can dock them, you can move them around, you can put them anywhere you want. In this case, I like the preview at the bottom. I have a couple of other windows here, one with my project, another with a connection to a database. In this case, two databases that I'll be working with pretty extensively in this demonstration. One being connected to a traditional transactional database, and the other one being my data warehouse. And on the screen here, you see we have our document windows, and the document windows contain basically the meat of what you're particularly working on. In this case, it is a data flow. So 90% of what you're working on is a data flow that's used in conjunction with the toolbox, and here are all of our sources, including our database sources and flat file sources, our destinations, including files and databases, and they're pretty much everything else is either a transformation or some sort of aid to facilitate that transformation or a logging mechanism. So on the main screen here, we have our data flow, which consists of actions and maps between the actions. So just a shorthand here, we have green for the sources and yellows for the targets. So let's take a look first of all at a data flow where we will be looking at how you can use data profiling. So let's look at this one here. So here you can see that we have one database that we're reading from. In this case, the green boxes here. We're joining that information in this transformation, and then we are writing that to our several logging mechanisms. So we're not actually migrating any data at this point. We just want to generate kind of a report and see how our data conforms to the way that we expect it. So we do that by making use of the data quality rules transformation. So this transformation here. You'll find it in the data profiling section. And you can see that we had just drag and drop, and then you have a box here with a structure here. So here I've already defined it, and I've already mapped it. So here you can see that between my data set here, which looks like this, okay, I should probably limit the number of records we have here. Let's take it to 50 instead of, there we go. So here I got 4 records out of there. And now out of this data set, I want to perform a data validation rule check on it. So I'm going to go ahead and open the properties for it. And what I want to do is I want to make sure that the computed total matches my subtotal. So I have just one rule here, but you can see that I can add many rules. So I can have a whole battery of tests that my data must go through before it actually reaches its final destination. So in this case, I have my computed total must match the subtotal. That is that the aggregate that I'm computing for the inherent tree structure here. So here you see that I have a tree join with a master record being the sales order header table, and then my child table being the sort of sales order detail table. I'm summing up all the sales, basically the sales amounts, and comparing that to what I have in the subtotal field. So normally this is a field that might be triggered by a trigger in the database, for example. But you can see how you might be out of sync here. So what we want to do is we want to flag those records and find out whenever we have the subtotal is not equaling the computed total. So for that, I'm going to go ahead and use a data quality check. Any place where I see that that rule is not satisfied, we're going to go ahead and stamp an error onto this record. And now once that record has been stamped with the error, we can go ahead and use it in a variety of different ways, including using the field profile. So let's go ahead and take a look at the field profile here. I'm going to go ahead and set it to 0 so I get an entire kind of snapshot. So this kind of jumping ahead to the development section, you can see that this is a very powerful tool, also not just in, from a business perspective of find data profiling and generating some report for someone else to look at. This is also very useful as you're developing. In fact, I can very quickly say quick profile at any section in the data flow and get pretty much the same information. So not only is this a good reporting tool, it's also pretty handy in development as well. So here you can see that I've gone ahead and I've generated a lot of statistics, including the warning percentage, error percentage, how many zeros, how many blanks, how many are distinct, total items, sum, squared, sum, median, any statistic I could possibly want I have available to me from the field profile, including the statistics about the field that I attached the data quality rule to, which is the computed total. And here you can see that for error percentage, I have an error percentage of over 25%. So you can see that this is a very high error percentage, and it might influence the decision going forward, whether or not I want to go through with this particular run of my data migration. So in this case, I can take this information and I can send it to somewhere else. In this case, I'm sending it to a delimited file. You can see where maybe I'm going to send this to an Excel file for a business analyst to mull over and bring it up in the next performance meeting. We can also send it to our own custom profile, in which case the custom profile is basically the same information, only that you see it in Centerprise custom UI here. So basically it's the same information, it just allows you to see it in a kind of a nice little manner here. The downside of using the built-in profile is that you can only see it with Centerprise. So if you need to export this data beyond Centerprise, you probably want to send it to either a delimited file, an Excel file, or what a lot of our customers do is they'll import this data into yet another database and database tables to keep track of the metadata about the run. And then finally, we can use this information by setting variables. In this case, I have a variable which is error count and total count. I'm going to set these based on information I get from my field profile. So here you can see that I'm taking aggregate information, and then I'm setting variables in my expression here. So doing so, you can see the expression set variable total count, error count, and now as this data flow has completed, I now have the ability to use it in my work in another workflow, for example. So let's say that before I start any sort of further processing, I want to first make sure that the data I'm working with is valid enough or meets a certain threshold before I continue on the rest of my processing. So here you can see that I have error count, total count, and I'm using a decision transformation. I could use a decision transformation to then decide whether or not I want to continue processing or maybe stop right there and send a notification out. Now, in this case, I'm using this as part of an overall workflow step. Just keep in mind, though, that since we are talking about data warehouse, we're talking about very large amounts of data, large number of records. So doing something like this might not even be feasibly possible, just because anytime you're dealing with a data warehouse, you have to keep in mind every scan of the database, every load across the network that you're sending in order to do this. So, which brings me to performance point number one. Centerprise typically, for the most part, operates outside of the database, meaning that you typically don't have it on your same machine that you have your database server on. It should definitely be on the same network as your database servers, but it typically is not on the same machine. So you have to keep in mind the bandwidth that's flying across between Centerprise and your servers. So this is the data basically on the front end using validation. You can also have an example where you're using data quality checks on the back end and using it more for a logging mechanism. So for example, let's take a look at this example where I'm going from my transactional database, including basically my sales order, the same relationship, sales order header, and eventually going through a data quality check again, and eventually landing up in my fact, a series of fact tables. In this case, I'm loading a single fact table. So what I want to do here, though, is I want to log the information that I gathered from my data quality rule. So what I've done here is I've created a route, and I'm going to send my bad records to a record level log. So the record level log is a component that you can use straight away in Centerprise and attach it to any box or any action in a data flow. So typically what you're going to attach these to, though, is you're going to attach them to the target. In this case I'm not, but just to save the complexity of this flow, I've attached it to another action. So the way this works is that you attach it to basically the output of an action, and anytime the record has an error, we'll record that error, and you'll be able to see it in a format such as this. So in this case, I have a rule called tax amount not in range, and now I've spit out that custom error message, and I have it available to me in this view here. So I can view the entire record, and I can view the error about that record all in a single user interface. This has the same problem as the built-in data profile, in that I need Centerprise in order to be able to see this information. Now you could process information further if you have knowledge of XSLT or are very adept at processing XML, because after all, that's all this is, an XML file. But most likely you'll probably have some other sort of system if you need to export this data beyond Centerprise, in which case here I've just dumped it to my own custom Excel file. Or you can send this information to another database as well. Which brings me to the third point when you can use data quality, is to actually route the records. So another best practice is to divide the data into different buckets. So for example, I've separated the data I need to process from the data that I need further processing. Basically what I mean by that is the data that just goes directly straight away to the fact table, and then there's data that does not meet a certain threshold and needs to be routed to further processing. In this case, I've sent it to a custom, a custom log Excel file. But you can imagine where I might have an entire system, an entire subflow that handles erroneous records, and maybe it dumps them in yet another database system somewhere. So that is the data profiling capabilities. Let's go ahead and go back to our. So again, you can use data quality for profiling. and validation on the back end. So the second major component when dealing with data warehousing is dealing with the translation to a star schema. So no matter if you're loading from files, some other services, or most likely another transactional database, one of the things that you have to keep in mind, you have three things basically to keep in mind in Centerprise, and that's number one, the biggest thing is foreign keys, how to deal with foreign keys, and such as the dealing with lookups between tables, and as well as the maintaining hierarchy and relationships between tables as they move from an inherently different type of schema, from a relational model to a star schema. Then you have your dimensional table maintenance and how you can use Centerprise to help with that. And finally, aggregate table maintenance and how Centerprise can help you create aggregate tables as well as update aggregate tables. So let's go ahead and look at, first of all, let's look at the first order of business when doing this, and let's stay with the same example, is the lookups. So here you can see that I have a series of different lookups here. So let's take a look at what I need to translate. So in our source here from our line item table, we have a field here for product ID. So if you're to look, this is the product ID and this is the key for this particular table, not necessarily what the product is known by, so such as a SKU or a product number. So the first thing we have to do is translate the product ID into a SKU, and we're going to do so by looking at the product. So let's take a look at what the product table looks like here. And here you can see that I have, by the way, just as an aside note, you can use this database browser as a development tool and be able to kind of see the data that you're working on right away without having to switch tools. So here you can see that we have our primary key for this table, and we have our product number. Just if I might ask, can someone mute their microphone? Because I'm getting a little feedback here. One of the panelists, I think, has a, okay, that's much better. So here we have the product ID, which is the primary key, and then we have a product number, which is the, could be considered the SKU number. So the very first thing we need to do is to translate that using a lookup. So I'm going to go into our toolbox and go under the transformations, and you'll find that we have a wide variety of lookups, including the database table lookup, the SQL statement lookup, which is basically the same thing. It just allows you to write your own SQL statements. And then we have list lookups, file lookups, any sort of lookups that you can imagine that be useful. Centerprise has them. You can use them in such a scenario. Typically, though, when dealing with data warehouse, that you're going to be using a lot of database table lookups. So the idea is that you map into it. So in this case, I have my product ID, and I get my product number, which is that SKU number, on the outside here. In this case, I have back-to-back lookups, and that I'm using that SKU number or product number as the lookup in the dimensional table lookup in order for me to get the product number for my fact table, because these are inherently different keys because they're different systems. A lot of times these might be generated by the system themselves, so they're completely, this product ID key, product key here is completely different than my source system's product key. So here I have back-to-back lookups in dealing with product tables. I also have the same situation for customers, and I'll get into optimization and how this you could reduce the number of lookups, which is highly desirable. But for the demonstrations of this particular example, we have back-to-back lookups, and I just want to kind of stop here to address when you want to use these types of lookups. So this one is an excellent candidate for a lookup because it is a product table, and you probably don't have a lot of products. Even if you did have a lot of products, it's probably not a lot in relative terms to the amount of records in a data warehouse. You might have several hundred, several thousand, but you probably don't have a billion products. So tables like this, it's very okay to use a lookup. In fact, you can use the caching mechanism that you use is also okay. In this case, it's the static as low as after cache, but I will get into that a little bit later. But this type of, anytime you have a record set which is pretty much finite, and it's going to be repeating a lot. So let's say, for example, I have a lot of sales orders, and a lot of these sales orders are referencing the same product. So in this case, I have the ideal situation for a lookup. Now, one that might be typically less ideal is the second example here, where I am looking up customer. The reason is that this, unlike product, I have theoretically an unlimited number of customers. I might have one customer per sales order. So in this case, now what I've done is I have one scan of one table here, and now I have one scan of another table here. So these are come as two separate requests to the database, and in which case may result in unnecessary overhead. So in cases like this, it might be beneficial to move these lookups and move them to the front side where you're actually retrieving all the data at once. So this is so just keep in mind that because you're dealing with fact tables, and the fact table is pretty much just some fact with a bunch of keys, that you're going to have these a lot of lookups going around. So to do so, you're going to use the database table lookup. Make sure you use the caching features, and I'll get into that a little bit more about the caching features in just a little bit. So that is number one. The number two item when we're talking about foreign keys is loading dependent tables. So for example, let's take a look at this data flow where we are going into our transactional database for this one, and we are getting information from an XML source. So our XML source looks like this. We have a bunch of records. Each record has an order. The order has attached a customer. It has some line item information about it. And what we want to do now is we want to insert into multiple tables. So let's go ahead and first of all, let me bring up my thumbnail here just to make it a little easier to navigate. You'll find this under the View section in 6.0. So here I have two tables that I need to write into. I have a very clear parent-child relationship here. So I have my sales order header, and then I have my customer. So I cannot have a sales order header unless I have an existing record in the corresponding customer table. The problem is, in this example, I have an XML file which may or may not have an existing customer. So for the records which do not have a customer, I'm going to go ahead and then insert them into the section, basically this guy here. So there's basically three ways to do that. So let's go ahead and move back to writing to related tables. You can retrieve the key from a single record insert. You can do a dynamic lookup, which I'll show, or you can generate the key to form some sort of temporary relationship and then use that temporary relationship in a subsequent step. So let's go ahead and look at those first. So let's look at the first example here where I am doing exactly that. I am using the lookup here. In this case, I am targeting the customer table, and if I do not see that, so first of all, I set the lookup options to no error message. So actually, I should say no message, and assign null. Doing so, I will then check for nulls in the route. So if I do find a null in that field, I'm going to say the customer does not exist because I did not find them in my initial scan of the customer table. The default option is the customer does exist, and I'm going to go ahead and just proceed as if everything's okay. I can just go ahead and write into my sales order table. If I do not have the customer record, I need to go ahead and insert them. So you can see here I have the option for insert for customer table, and then I have what I'm going to do then is join the output of the customer table, and I'm going to join it with the rest of my record. So basically I'm splitting it in order to insert it, and then I'm joining it back in the join transformation, and then finally I'm going to union both types of records, the customer exists and customer does not exist, into the union transformation here. So so let's take a look at how this works with the customer in scenario number one. So scenario number one, I'm going to insert into the customer table, and I'm going to retrieve the generated customer ID because the column for customer ID is an identity column in this one. So in this case, it could be an identity column if you're talking about Oracle databases, you're talking about a sequence object. In either case, SQL Server, Oracle, or DB2, the mechanism is here for you to use. You insert into it, and then you'll get the corresponding generated numeric value on the output. So then you can then use this output and forward it to the subsequent write. So a couple of caveats here. One is that in order for this to work, you must use the single record insert option, which is here. This will not work for bulk insert. So in fact, it will not tell you that it won't work, it's just that it will not give you the return value. And the reason is because when we're dealing with bulk, we're sending a lot of records all at once. We are not going to make a query for every single time we insert a record. As opposed to single record insert, what happens is that you send the insert query a SQL statement, and then right after that we get the identity or the current sequence object on the subsequent select statement. So basically, we're effectively issuing two statements per pass-through of this customer item, per insert of the customer table entity here. So the caveat here, another caveat, or not caveat, but downside of this approach is that it is very slow, as you can imagine. So we're talking about a very high number of records. Doing this will result in very poor performance for this particular load. The benefit is that you're relying on the database to generate these keys, and you can basically guarantee referential integrity. Okay, second approach is to use a dynamic lookup. So this is now the recommended approach for this situation. In that, the way it works is that we're using just the standard lookup, which you find in the toolbox. So here you see we have database lookup. And the way it works is that we will go into the properties of the lookup. So again, we're pointing to customer table. And we're going to choose for the lookup cache type, we're going to use dynamic. So also with this dynamic option, we're going to choose fill cache with all lookup values at start. So this will result in a very large initial query to this table. But the good news is that it's basically scanned one time. After you've scanned it, you're ready to go. And you're going to want to choose the cache key column. This is basically the output of your lookup, or the key that you're looking for when you're talking about a dynamic lookup. Then you have your other options. In this case, I want no message, assign null, as always. And now that I have that, since I've chosen the dynamic option, I have another node here called dynamic cache. So the dynamic cache is going to give me the cache action object here. So if I were to preview here at this stage, this gives me the lookup, and it also gives me the dynamic cache action. So here you can see that it's insert. And the reason why it's insert is because this particular account number was not found in my customer table. Therefore, it went ahead and generated me a new one. So the dynamic lookup kind of has an inbuilt sequence generator into it. So it'll select the highest number found in this particular table and then get me the next new one. So this works when Centerprise is generating the keys. And that's one of the things you have to keep in mind when using dynamic lookup. So if it does find the corresponding customer ID, as it did in this one, it went ahead and found it, and there is no cache action, so it's null. So I can then use that in a route transformation, just as I did before. In this case, now I'm checking the cache action, not anything else. And if the cache action is set to insert, I know that the customer does not exist, and therefore I must set it to I can send this to basically for customer to be inserted. Otherwise, I can go straight away to my dependent sales order header table. So notice that this one is much simpler than the previous example. I don't have to worry about a complex logic in order to write into both tables. And now I've basically generated a new key, and this new key is not yet inserted into the table at this point. That will happen only with this. So now I can use this key for both tables, for the sales order and the customer table. So the last thing left on our list now is to make sure that the customer table gets inserted before the sales order header table. So the way to do that is to open the properties for the database write and select the used constraint based write. So as soon as you choose this option, you notice that all of my other bulk insert options disappeared, because now I have to write everything basically in one batch. So I will write all of my customer records first in one batch, and then I will write all of my sales order records all in one batch as my next step. So in this case, I'm dealing with just 2 tables, but you can extend this to n number of tables. The more complex the tables, the bigger benefit you get from using this option, and the bigger benefit you get from Centerprise, as far as having to develop this yourself in a very complex data flow. So that's the second option. The third option would be to use some sort of temporary keys. And so for that, we have the object called the sequence generator. So like I mentioned with the dynamic lookup, where it had a built-in sequence generator, Centerprise also has sequence generators outside of the dynamic lookup. So you will find these in the toolbox. And here we have the sequence generator. And if we open the properties for the sequence generator, you can see that we have in-memory and database table. Typically, in-memory is used for things such as indexes, but for situations such as these, you're going to definitely want to use the database table. So selecting the database table, it's going to ask you for the connection to the sequence, where this sequence is stored, and then the sequence object name. So it's very similar to, let's say, a sequence object in Oracle, but it's completely outside. It has nothing to do with any particular database. All it is the table, which stores a number. The next time you need the next number, go get me that number in batches of 100. So let's go ahead and see where those sequences are stored. So let's go to Google Tools, Sequences, and you'll get presented with this screen. In this case, I'm going to pick my Centerprise database, click OK, and you can see that I already have a sequence defined with my current value of 1. I can change this, and the next time a sequence is used, it will be used in batches. So rather than coming to this table every time, we're going to basically generate 100 at a time or 1,000 at a time, and then I don't have to worry about performance as far as hitting that table multiple times. So now that I've defined my sequence and I can use it now I need to insert into a particular table. So in this case, I need to use some sort of external key. So in this case, I'm going to hijack this row GUID table, but I'm sorry, I've defined one already called the ETL key. So this is an external, kind of an additional column that I've used just for ETL processing. So the idea is that now that I have this key and I have it available to me, I can now generate my own sequence, pass it in here, generate the same sequence for the other table, and now I've maintained this temporary relationship between the customer and my order table. So now in a subsequent step now I can go, for example, not this one. I don't think I have it here, but basically what it would be a workflow where I would load the customer first and then the orders second. And then I'd probably have to make use of some temporary storage, either some file where I'm writing to these two entities where now I have that relationship, or I'm writing to, more likely, a series of staging tables, which I can then query and then write into the final destination tables. So this would be a two-step process rather than one data flow. The benefit is that it's basically doing the same thing as I did before with the dynamic lookup. It's writing one set of data first and then writing the other set of data second. The downside of this is that you can see that for every single table now I need to have a separate staging table or maybe a temporary file. So this can get quite complex, and it's, well, not slow, it might be developmentally a hindrance. So let's go back to our slides here. So let's take a look, review each one now. So when writing to related tables, you have method 1, retrieve key from single record insert. Pros can rely, if you have the requirement that the database must generate this key, you can use this option. Cons is that it's very slow, and it usually requires a secondary identifier to join the records once you've inserted the records into the database. So in this case, in our customer, we have an account number and product, we have a SKU number. We need something like that in order to achieve this method. Method number 2 is a dynamic lookup, and that is, the pros are it's fast, it's easy, it's kind of intuitive. You just mapped into one table, map into the other, and it's pretty, it's very easy to develop. The cons is that you cannot rely on the database key for key generation. In this case, Centerprise will be the one generating the key, and all records must be written in the way that you cannot do chunks as you could. And that, by the way, that's the preferred method at this point. Third method is to generate a key from and form a temporary relationship. The pros is that's still fast. You're still writing records in very large chunks, and the best part is that you can still rely on the database to generate the keys. The bad part is that it usually requires several steps to achieve this, usually the staging table. It's very complex. It makes your data flows a lot more complex and therefore more high maintenance. So that takes us to, I jumped ahead a little bit. So that takes us to the dimension aspects of Centerprise and how Centerprise can help loading your dimension tables. So let's take a look at a data flow that I've already prepared here. In this case, we have made this very simple, kind of overly simple, so we don't have to deal with too many boxes. But in this case, we're going from our transactional product table and loading a dimensional product table. So what I've done here is I'm taking use of our slowly changing dimensions component, because we're going to observe all the roles as far as slowly changing dimensions when loading our dimension table, meaning that there are some fields which we can update right away, such as, for example, color. We can change the color, no problem. So anything that happened in the past, we can still, basically, we don't care. If it was red before, it was now. But there are some things that we cannot change, such as, if I look at the properties here, we can get a good glimpse of that, is the, something like, for example, the start date. So we can't change when the actual product, or let's say the days to manufacture. This is something that we cannot change. We're going to go ahead and say that this is not used. Basically, anything that not used cannot be allowed, or update not allowed. So if we get an update to this, it's going to flag an error. If we get an update to color, it's going to trigger an SCD, slowly changing dimensions type 1 update, in which case we will not worry about it. It's just going to go ahead and generate one record to update. Then we have the list price, which is going to, basically, we want an archival history of all products and their list prices in the past. So in this case, it's going to trigger an SCD type update, in which case it's going to generate two statements, an update and an insert statement. So this is a typical scenario where you're writing to a dimension table, and Centerprise can make use of this component to help out. So you're going to define your surrogate key and your business key, and then you're going to define your start and end expiration dates, as well as if you have a current record designator. So when you're using this component, you're going to typically point to the same table that you're trying to write to. Now, it's not necessary. You could, let's say, for example, use this SCD component to write to, let's say, a temporary table or a temporary file. But in this case, we're going to write to the same table. So let's go ahead. So let's take a look at what happens when we preview this now. So I've made some changes in the product table, and you can see that I have my SCD project path here. And at the end here, I have right strategy action is update, insert, and update. So here you can see that I'm updating some records, and I'm inserting one where I made a change to line the line list price. So it went ahead and first it updated the record, changed it, put the end date effectively right now, and it created a new record and set the end date to null and marked the status as current. So basically for one record it went ahead and generated two records. So this is an example where you can make use of the solely changing dimension table to write to dimension tables. So the third way you can use Centerprise as far as the star schema and writing, helping writers here. So in this case, what I'm going to do is I'm going to take a fact table and I'm going to create. I've done some analysis on how this database is used, and I've identified that the fact internet sales table is queried many times, and basically I can reduce this fact table to an aggregate table to help me in subsequent queries. Now, Centerprise won't actually do any sort of query manipulation or query substitution. That's entirely on your systems to deal with that. But as far as maintaining these aggregate tables, Centerprise can help with that, either in initial building. In this case, I've selected to rebuild the table. So I'm going to use the aggregate transformation, which I'll find in my toolbox, and compute based on grouping by product, key, and date, for example, and get me a nice little aggregate of the basically information already in my fact table. So here I've got the total sales by product number and by date. So this will help me reduce the amount of queries theoretically coming out of the fact internet sales table. So once I've done that, though, again, this is a data warehouse, so this scan, computing this aggregate, might be prohibitively expensive. So I might want to just increment the aggregate table incrementally. Centerprise can also help with this approach. In this case, you can see where I'm querying two records, joining, and then computing the aggregate, looking up the aggregate, and then using an expression to augment or basically update that record in the aggregate table. So this has the obvious pros and cons in that the pro is that now it's a lot faster than computing the aggregate every time. The con is that you're susceptible to errors here, so you have to be very careful and ensure that the processes that you've found that you follow are up to snuff and can withstand, are robust enough to be able to tackle this approach. So, but if you do choose this approach, Centerprise can help with aggregate tables as well. So moving on to the next section here, we have I want to talk about performance, and there's basically four areas of performance in which case I would like to address, which is one is querying data, caching, and let's take a look at Centerprise in that. So let's go back to one of our examples here, and let's take a look at the fact internet sales load. And here I have my lookups. So in the first lookup, this is a very small lookup table, and I'm going to be using cache. I'm going to be using cache types here. So by default, it's set to no caching. Best practice, you always want to use caching. There's really no reason not to use caching unless you're worried about memory consumption. The good news about Centerprise 6 now is that all of the stuff is stored on disk, so you really don't have the memory issues or concerns that you did in previous versions of Centerprise, so there's really not a whole benefit to using no caching. For the very least, you should use the static caching, and by default, it's set to fill cache with lookups at start. So keep in mind when dealing with a data warehouse with very large records, in that doing so will result, if you're dealing with data which is not repeating, will result if you have n number of items you need to look, records that you need to look up, and there's n number of items that you are hitting for basically distinct items for the lookup, you're going to have n number of queries. So if you have a billion records, you're going to end up with a billion items in SQL statements back and forth, round trip to the database. So if that sounds unappealing, you might want to take advantage of the cache after. I'm sorry, this is the default option. This is what you might be using if you have a very small data set. But typically you're going to want to use the fill cache with all lookup values at start if you have a very large source data and the type of records that you're looking up aren't conducive to the cache after first use. So for product, cache after first use is fine because we have a very small number of products. For fill cache with lookup values at start, this is good for very large tables where you're not where you're basically going to be looking up all that information anyway. So another aspect when dealing with caching is maybe you don't want to use a lookup altogether. Another best practice is, for example, both of these lookups here are looking up the source database. So basically the same database that we have here. So in this case, we can eliminate this product lookup by simply going to the database and using this as part of our initial query. So rather than we have a join here, let's just do another join here. And then join these two pieces of information. So now I have 1, 2, 3 tables all in a single query coming from the database. So I've now just cut down on any number of queries that I've gotten that I needed for that initial lookup. So to take advantage of this, you'll first have to make sure that you choose join in database. And everything that's connected to these joins must be a database. You cannot use this option if you're joining a file, for example. But once you've chosen this option, now I've effectively increased the performance of my data flow quite a bit by reducing a single lookup. So another option that you might want to take advantage of is the persisted lookup. So you can see that where this customer is going to be involved, or let's say product is going to be involved in a lot of, it's going to be involved in a lot of dimension table loading. So in fact, I don't want to keep scanning this product table if I already done that once. So when you have that type of scenario, such as loading dimension tables, and you need to look up the corresponding IDs, you might want to take a look into the persistent lookup. So here I can say product, any lookup that shares this same label, I'm going to use across data flows. So now I just have a single scan of the product table, and no matter how many times I use it in subsequent data flows, I now have this just in one spot. Okay, so that is caching and querying. Writing, we have diff processor, and then finally parallelization. So on the right side, we have items that you can use for helping out to make sure that you're only sending the amount of data to the target that is absolutely necessary. So in that section, in Centerprise, you'll find a section called Database Write Strategy. And the two important ones here are the diff processor and the source diff processor. They effectively do the same thing, just in a different way. So the source diff processor is basically a record or a log of every time you run a data flow through Centerprise. It remembers the data state at that point. So subsequent runs will compare against that, and will then, let's say if I preview this, for example, we'll go ahead and skip information, skip records that need to go to the target. So obviously you don't want to update records unless they absolutely have to be updated. So in this case, you can see that I've automatically taken the skip and then update, and everything else is skipped. So basically now, out of all those records I've just scanned from my source, I'm only going to send one record to my destination. So this is, and it's not going across the network. It's staying basically between this machine, whatever that database is, and Centerprise. I don't have to go and query this database at all, except for sending my single statement. The second option is to use the diff processor, which in this case is a section here, and I'm going to be using basically it's the same thing as my source diff processor. The only difference is that instead of that file, that hash file that I'm comparing against, now I'm comparing it against the actual tables. Typically, you'll point to the same table, and you'll get differing results. For if the record is not there, you'll get an insert. If the record is changed, you'll get an update. But the idea is the same. So you're sending basically just one record to be updated to the target database. So that is the performance considerations when talking about Centerprise. Last and we'll get through this very quickly, is the development aspect of it. So when developing in Centerprise, you're going to want to take advantage of a couple of things. Number one is projects. Typically, when you're doing these type of data migrations into a data warehouse, it's going to be, a team. Could be a team of 5, 10. So you're going to be working with a lot of people. So when collaborating with other people in Centerprise, you'll definitely want to take advantage of the project. It fosters structured development, source control, reusability, and then we have options for built-in impact analysis and, of course, debugging mechanisms. So let's take a look at some of those. So from the beginning, I've been using a project here. So you're typically going to want to organize your projects in a different way. So let's say, for example, let's close all of these documents. And let's go ahead and by the way, I'm going to start asking for questions in about 1 minute. So if you have questions, please feel free to ask them. So let's go ahead and open project sample. So when dealing a project, we'd recommend that you group and you make use of folders in your project. So such as, for example, we have our purchasing node, our product node, our sales node, which has a bunch of different data flows. We have a common folder, which is going to take care of shared actions between things. So you're definitely going to want to make use of the project feature. It just makes for developing things much easier. So for example, if I create a workflow and I need to involve multiple data flows, I can just drag and drop them and connect them in such a way. And that basically the idea is that you're creating building blocks, and these building blocks will be used in the future. And that includes things such as shared actions, where I want to make reusable things reusable over and over again. So I only have to define them once. You're also going to want to take advantage of source control. Centerprise has built-in source control functionality to Microsoft's Team Foundation. But if you do not have Team Foundation, fear not. All of the files are just basically text files, specifically in XML format. So you have the ability to check in and check out the files. I can't stress this enough. If you have any sort of, not just data warehousing, but any sort of complexity in a project, you're definitely going to want to use source control. Having it just on a shared drive is not going to cut it. Accidents happen, things get overwritten. I definitely use source control. And then we have another handy feature when it comes to development is the database browser here, and specifically when we're talking about impact analysis. So for example, let's show the lineage for we're not using it here. So let me open the other project here. Let's go back to ETL. And oops, not this one. This one, sorry. And I should see my lineage builder here at the bottom. It'll tell me when it's done. It's ready. Okay, so now I should be able to show lineage. Now I have the lineage of that table and where it's used in any sort of data flow throughout Centerprise. So this becomes very handy if you are need to make a change in your data flows, or need to make a change in the tables, I should say, and need to see, okay, which data flows are affected by this. How big is this change that I'm making? So this is basically impact analysis. It's very useful when you're dealing with a large, complicated project in Centerprise. So last but not least is the debugging feature, and this you've seen plenty of throughout the demonstration. Basically, you're going to make use of preview data, which will show you the first n number of records, or 0. Set it to 0 to get basically everything. Caveat for this is if you set it to 0, you may have a problem with the amount of records that's coming back to display here, because if you have too many records, this is going to eat an exorbitant amount of memory on the client, maybe even causing a crash. So you only use zeros experimentally. If you're typically, when you're looking for 0, you're looking for some sort of information about the data set in its entirety. In that case, you might be better off using the quick profile. So with that said, kind of taken all the time, but I'm going to field questions here. and let's take, I'll try and answer as many of them as possible. If you'd like to stay on, we'll probably go on a few minutes over. So let's go to the first one. Can data profiling be used standalone? And yes, absolutely. So if you look at our example here for order analysis, that's exactly what I did here. So if we look at the targets here, I'm not actually writing to any particular data warehouse, or I'm not actually moving any data. All I'm doing is basically creating reports for that. So yes, you can use this information as a standalone piece. In this case, what I'm doing is I'm just gathering information about this this particular schema here. Number 2, can we group a bunch of data quality rules and use them in multiple flows? Sure. So let's go ahead and look at our data check here. In this case, I have a rule called tax amount. Let's say I can keep creating rules here and say, rule 1, and this rule will be attached to, for example, I only have tax amount here. In order for this to work, you got to map into it. So let's map in another field here. Let's say I have purchase order number. Purchase order number cannot be null. Okay, so let's go ahead and create a rule for that. So here's my rule, my data check, purchase order number. And by the way, these questions will be answered and available on our website shortly. So I can say purchase order number is not equal to null integer, for example. String. Click OK. So now I have multiple roles, and now I can make this a reusable component by just simply dragging and dropping onto the project, and you can see now that this becomes a grayed out kind of box, and now it is by reference. So now if I have any other flow, I can go ahead and use this data check, and basically it's by reference. I have it, and this is a very good practice to make. Anytime you have something that you can make reusable, do it. You'll thank yourself in the future. Okay, another question. Let's see here. You mentioned persisted lookup cache. Can you explain how that improves performance? Sure. So let's go back to the example here where we are using a lookup, and a good candidate for that is, let's say, this customer or this dimension product lookup, right? So this is something that's going to be used over and over in a lot of fact table loading. And I don't want to have to load this dimension table again. So you can see where this dimension table may have hundreds of thousands of rows in it, maybe more. So if I'm loading every single fact table, and in doing so, I have to load all the data for a lookup, you can see that all of my processing, all of the data going across when migrating data is going to be consumed in just lookups. So what I'd rather do is just look this up just once. So if I change this to a persisted cache, the way this works is that Centerprise has a built-in database where it will store this information, and it stores it on disk, so you don't have to worry about memory usage. And then every time you lookup uses this label, it will then consult that cache rather than making a trip to the database, because making a trip to the database is inherently expensive anyway. Making a trip to a very large table over and over again, and then basically retrieving all records is extremely expensive and can actually slow your processes down to a halt. So anytime you have an option to use a persisted cache, we recommend doing so. Okay, so what are the most frequent causes of performance issues in loading data warehouses that a user experiences with Centerprise? Number 1, data volume. Lookups, as I just mentioned, having too many lookups. Having too many lookups all in a row, or not in a row, but in a column. So let's say where I have dimension table, dimension. You could see where I have, you could see here that I have in my fact table here. These are all keys, right? So each one of these probably needs some sort of lookup. So if I have 10 lookups right before the dimension table, each one of those lookups has to complete before the record can be inserted into the fact table. So having a lot of lookups and a lot of inefficient lookups, I should say, will slow down the data flow considerably. Okay, so another thing which might impair performance is, for example, the initial query, right? So here, for example, we're taking the sales order, but the only thing we're doing is we are taking the sales order, and we are, well, I have it here now, but what you're going to want to do is parameterize these queries. So, for example, you can do that a couple different ways. Number one is you can use variables that control in the data from the outside. So, for example, let's say I have a workflow that triggers all my data flows, and then I'm setting this workflow is going to be for records that are, have been entered between this date and this date, maybe a week's worth of data. That's the only records that I'm going to read here. So it'll cut down tremendously on the amount of data going between the source database and Centerprise. Number two option, this is kind of this very similar, same thing, but I'm going to use the incremental load based on audit fields. So in this case, what I can do is if I have a field that I'm guaranteed to get modified every time a change happens to it, I can use this modified date as my audit field. So what's going to happen is it's going to store that information on a file. The subsequent times the data flows are run, it's going to consult that file and basically do the same thing. It's going to do the same thing that we defined in our where clause here, but it's going to do it automatically in that where file. So the benefit is I don't have to keep track of these variables. Downside is that now I have an incremental file per object that I'm loading from, which brings me to the point of you may even want these sources here to be shared actions. So that way you don't have to keep defining these sources and their audit fields. Okay, so then we had a question, does use constraint-based write automatically figure out the sequence of writing? Yes, it does. So if we go here to our, where were we at? We were at import orders, I believe. No, this one. In the second one, we have, we're writing to two different tables. Again, it doesn't matter how many tables you have, as long as they're related to the same, in the same database. If you choose the use constraint-based writes, it'll know which order to write it in. It knows that it has to write the customer first and then the sales order. So it'll write, it'll basically take care of the order of operations as writes accordingly. Next question, how does diff processor compare to the upsert performance? Diff processor is much faster than the upsert performance. Upsert is going to fire off another query to see if that information exists or not. If you're talking about the diff processor, the way it works is that all the records are sent in bunches to the target system. They are then written to a temporary table where they are then joined, and that comparison happens on the database side rather than on Centerprise side. So you can see that entire large chunks are happening and being compared on the database side as opposed to a separate query to find out whether an insert needs to happen or an update needs to happen. Okay, do you guys support fast load for Teradata? Yes, we support both fast load and multi-load. Fast load is automatically used when you are writing into an empty table. Okay, answer number, okay, so as an addendum to number 6, upsert does it one record at a time, just to clarify, and diff processor compares in batches. So diff processor is a lot faster, and in our process, in our test, it's been anywhere upwards of 300, 500% faster. Okay, so if there's no other questions, feel free to. I mean, that's all we have to answer at this time. We can keep going, but I think that's it for now. So if there's no other questions, I will thank you. Thank you for staying, those who have stayed an extra 10 minutes. I appreciate your time. And we will have a recording of this webinar up on our website, as well as the Q&A session, basically this Q&A session in written form available for download as well. Okay, again, my name is Mike. Thank you for attending this webinar, and have a good day.